What did you aim at with?
Start.
Now?
Yeah.
Alright guys, we are doing protein synthesis stage 2. I did stage 1 earlier, but I'm sorry I did forget to mention the codons, which is 3 mRNA bases, 3 RNA nucleotides if you want. So that is a codon. So we're doing the second stage of protein synthesis, which is translation, which involves tRNA, which I did say in the first video with the transcription. But just to go over, tRNA is a clover-shaped model structure, and the reason why it is like this is because there's specific hydrogen bonds between bases, only specific ones. So that's why it creates this clover shape rather than just a single strand, which is messenger RNA. The two important things you need to know about transfer RNA is that it's got an amino acid binding site at one end. So here, this is the amino acid binding site. And then the other end has got the anticodon, which is here. So they're opposite ends, and I will tell you what the anticodon does in the amino acid site. Well, you can already see here that the amino acid binding site binds to an amino acid, and that is key. So moving on, we're at that. This is a messenger RNA strand. This long chain here. This is just in the cytoplasm. So once the messenger RNA moves out of the nucleus, then it goes into the cytoplasm, and then what happens is a ribosome comes along and it forms around the messenger RNA. Now, the ribosome is moving in this direction, and then the messenger RNA is moving in that direction, so it's almost causing like a conveyor belt sort of thing, picking up the transfer RNA. So the transfer RNAs are coming from this direction, and what I've done is these are meant to be transfer RNAs, but it actually looks like this. So just to simplify things, that's what I'm doing here. So what happens in the ribosome is transfer RNA comes along, and the anticodon, which is these sort of 3 poles, attaches to the codon, which is on mRNA. So the RNA nucleotides are 3 and 3, also known as a triplet, but codon as well. And then the anticodon binds to that complementary shape. So basically what happens is once these 2 transfer RNAs are in the ribosome, ATP is used to bind the 2 together, forming a peptide bond between the 2 amino acids. Now once that happens, the amino acid is left behind, and then the rest of the transfer RNA, the anticodon, and the rest of it moves off. That goes away. So imagine that. I'll rub that out, and the rest of that goes away off, and the amino acid is left in there. Now, this happens, and then basically the whole thing shifts this way. So imagine the transfer RNA is shifting this way, and I'll draw it here. So I will draw our 2 amino acids here. Yeah, we'll do it like that. No. So we've got our amino acid which came off of here, like this, and this will be bonded to the one which was originally here, which is now here. Now this one here will move in like this, over to this place, and then this one will form a peptide bond, like that. Now what happens is, now this is the second one, which was originally here. This will break off and go up here, and this bit we don't really care about. And then this one will move on. And what it will do is, it will create a continuous chain of amino acids, and once it gets to a stop code, so one of these may be a stop codon, and it will just stop the whole process. And then we'll have an amino acid chain within the ribosome, and it will form into a 3D structure, also known as a protein. Thank you for watching. I will catch you next time.